But wait a second, you might say, if you recall when we were talking about logical equivalence. So recall the definition of logical equivalence. Two compound expressions are logically equivalent if they take on the same truth values, no matter what the truth values of their underlying variables are. That sounds suspiciously similar to this biconditional right here, because the biconditional is true if and only if the left-hand side and the right-hand side take on the same truth value. Well, it actually turns out that the concept of logical equivalence and the biconditional are completely the same. So let's go ahead and demonstrate that. The biconditional and logical equivalence are completely the same. So we saw a couple examples of logical expressions that were logically equivalent. So in particular, we already saw that P is logically equivalent to not P. We already saw that in a previous video. So let's go ahead and take a look at what or how this relates to the biconditional. So in particular, if you recall the truth table for this guy, we had P, we had not P, and then what I'm going to consider over here is P if and only if not P. So we recall from the previous video that these two were logically equivalent. That means they had the same truth table. So this was a true and this was a false. They had the exact same truth table. Well, this biconditional right here, it's true if both P and Q take on the same truth values. So both the left-hand side and the right-hand side of this biconditional right here take on the same truth value. Well, the left-hand side of this biconditional is true, and the right-hand side of this thing is also true. So that means, by our definition, that this thing is true. And if we look at the second row right here, the left-hand side is false and the right-hand side is false. They both take on the same truth values, so this thing here is true. So this right here means that P is logically equivalent to not P, is saying the same exact thing as P if and only if not P right here. And we saw another example of logical equivalence. So the second example that we saw was that not P or Q was logically equivalent to not P and not Q. And we wrote down the truth table for this, and we saw that the truth table for this was and if you look back in our previous video, you could see that what we had was that these two were logically identical to each other. They were logically equivalent because they had the same truth table. So if we were to extend this thing and look at this very compound expression, not P or Q, if and only if not P and not Q, right here, let's go ahead and see from this definition right here what we get. Well, from this definition, it's true if the left-hand side and the right-hand side take on the same truth value. Well, yeah, they're taking on the same truth value there. they're taking on the same truth value there, they're taking on the same truth value there, and they're taking on the same truth value right there as well. So we can see from this that what we get is not P or Q, if and only if, not P and not Q. So the main takeaway from this discussion right here is that logical equivalence and biconditional are the same exact thing. So if you have P is logically equivalent to Q, you know that that's the exact same thing as P if and only if Q. That's why oftentimes if a mathematician or a computer scientist proves that P if and only if Q, you know those concepts are basically completely identical. So kind of like an analogy, it's just a different way to look at the same thing. Logical equivalence, we looked at, they have the same truth tables right here. And for biconditionals, we're looking at if the left-hand side and the right-hand side take on the same truth values. It's just two different ways to look at the same thing. So for example, by analogy, if you wanted to identify me as a person, you could, for example, take my social security number. That is something that uniquely identifies me. Or you could take my Penn State ID number. That is something that uniquely identifies me. It is just two different ways to identify the same exact concept. So logical equivalence and the biconditional are actually the same exact thing. It's just two different ways to look at it. And sometimes when you try to prove something, it's easier to show via a truth table that they are the same. Or other times it's easier to argue by using the biconditional and showing that the left-hand side and the right-hand side take on the same truth values. So this concludes all of our basic propositional logic operators. Not, and, or, XOR, implication or conditional, and the biconditional. After this, we're going to look at a few practical applications of this and look at a bunch more examples and ways that we can actually use all this structure that we've been able to build up in a short amount of time.